All right, these are your balancing equations notes. You will need to write them down in your journal as we go through them. So the reason that we need to balance equations really comes from the purpose for stoichiometry. So stoichiometry is the study of quantitative, which just means numbers and calculations. So quantitative relationships between the amounts of reactants used and the amounts of products formed in a chemical reaction. So it just is looking at the amount of stuff you start with, the amount of stuff that you end with, and the relationships between those things. So in order to perform any of those calculations, you must first have a balanced chemical equation. So balancing equations comes from the principle or the law of conservation of mass, which says matter can neither be created nor destroyed. This is true when it comes to chemical reactions as well. All right, so if I start with a certain amount of reactant, so compounds, atoms, whatever, I'm going to have the same amount of stuff at the end. It will have changed what it looks like and what properties it has. So this often means we will need to balance our chemical reaction equation. So up at the top here is where we have our chemical reaction equation. All right, so CH4 plus 2O2 yields, right, that's the arrow, yields CO2 plus 2H2O. So reminder, everything in front of the yield arrow are your reactants, or that's what you start with, and everything after the arrow are your products. All right, so that's everything you end with. So you can think about the arrow kind of as the reaction takes place and then makes this. So you'll notice that there are coefficients, which are the numbers that are in front of the molecular formulas, and that helps make the number of atoms equal. All right, so we have the picture down here to kind of illustrate that. So C is this little black ball, H's are the tan, O's are red. So in the reactant side, I have 1 carbon, I have 4 hydrogens, and I have 4 O's. Now you'll notice I only have 4 because I have 2 of the O2s. So if I didn't have 2 O2s and I just had 1, then I would only have 2 oxygen atoms. On the reaction side, I also have 1 carbon. I have 4 hydrogen over here, all right, and then 4 oxygen atoms. So if you're counting these up top, you count 1 for whatever it is, unless there's a coefficient, right? So then I multiply. So to figure out how many oxygens I have right here, I say, okay, I have 2 times 2, so that's a total of 4. Whereas if I don't have a coefficient, this would just be assumed a 1. So 1 times 1 for carbon is 1, and 1 times 4 for hydrogen would be 4. So the same is true on this side. One thing to note is that this coefficient 2, whenever I'm multiplying it out, I distribute it, all right? So I multiply it times each element. So I would say, okay, I have 2 times 2 hydrogens, so that's a total of 4. And then I have 2 times 1 oxygen, which gives me a total of 2, all right? And then in order to get this 4 oxygen down here, it would be, okay, the 2 over here plus the 2 right here gives me a total of 4 on this entire side. So whenever we're balancing, it's important to know how to count up how many total atoms you have on each side of the arrow. All right, so here's some more examples of reactants and products where you have carbon plus oxygen gives us carbon dioxide. All right, and that one's already balanced because I have 1 carbon and 2 oxygen on both sides. Now if I'm looking at this reaction that has the use of a catalyst, so a catalyst just speeds up a reaction. So if you ever see anything like platinum right here above the arrow, it doesn't actually take place in the chemical reaction. It just helps it go faster. So any catalyst I have that I start with, I end out with. It doesn't change in any way. So if I have hydrogen and I add it to oxygen with the use of platinum, I can actually make water. So this is a really useful reaction, but you'll notice starting off, I have 2 hydrogen atoms, 2 oxygen atoms, and when I end, I have 2 hydrogen atoms and only 1 oxygen atoms. So my equation is not balanced, and in order to do calculations later, which we will do, we have to have a balanced chemical equation. So I'm going to add a 2 in front of my water, right, because I'm trying to get 2 oxygen here. So that would make my oxygen 2, but it would also change my hydrogen, right, because 2 times 2 would then give me 4. So 4 hydrogen atoms and 2 oxygen atoms. So I just balanced my oxygen, but in the process, I unbalanced my hydrogen. So in order to make them equal, I'm going to come over to this side. So okay, if I put a 2 here, then 2 times 2 hydrogen atoms would give me a total of 4. And now it's balanced. All right, so it's kind of one of those, it's kind of like a puzzle, give and take. So here's just another picture of H2 plus Cl2 goes to HCl. You'll see that it's unbalanced. So we got two H's, 2 Cl's, but I only have 1 of each in the products. All right, if I added, put a 2 in front of the HCl over on this side, all right, then it becomes more balanced, where I have 2 H's, 2 Cl's on the reactant side, and I have 2 H's up here and 2 Cl's on the product side. So it's balanced. So just a reminder of what a chemical formula means. So you have the symbol. It means that there's 1 molecule of water, all right, and this is what it would look like. And that 1 molecule of water is made up of 2 hydrogen atoms and 1 oxygen atom, okay? If I have 2 H2O, that means that I have 2 molecules of water. So this is the picture here. And that means I have 4 hydrogen atoms and 2 oxygen atoms. All right, so another way to do it is the multiplication. So 2 times 2 is a total of 4 hydrogen, and 2 times 1 over here would be a total of 2 oxygen atoms. And finally, H2O2 means 1 molecule of hydrogen peroxide, and that just means 2 hydrogen atoms and 2 oxygen atoms right here. All right, so some tips for balancing equations. Balancing equations always seems to be, it's kind of like riding a bike. You might struggle with it, you'll struggle with it, you'll struggle with it, and then all of a sudden you've got it, you can't do it wrong again. So it's going to take some time and it's going to take practice more than anything else. So I came up with 4 tips. They're not really rules or steps, but tips for balancing equations. So number 1, write all of the chemical symbols under the reaction arrow. And in a minute, I'm going to show you what I mean by this. So number 2, start with the elements that are not hydrogen or oxygen, and then circle back to balancing hydrogen and oxygen. So most of the time, it's easier to start with other things like metals or other elements. Number 3 is look for the common denominator. So if I have on one side I have 2 and on the other side I have 3 of the same element, then I know there's no way I'm going to get both of those to 4 by multiplying them, right? The lowest I could get a 2 and a 3 to would be 6, right? If I multiplied the 2 by 3 and if I multiplied the 3 by 2, I could get them both to 6. So looking for the common denominator sometimes is helpful. And then number 4 is balance the elements that are by themselves last. And you'll kind of see why this is helpful in a moment. So we're going to work through this practice example together. So we're going to balance the chemical reaction equation below. So remember with my first tip, I said to write the elements under the reaction arrow. So I have the reaction arrow here. And then I have written all of the elements in my equation down the middle, and I just wrote their symbols, okay? Then I'm going to count up how many I have to start with on each side. So if I look at chromium, I have 2. For oxygen, I have 3. And for magnesium, I only have 1. And then on the product side, I only have one of each. So you can see that it is not balanced. So my first step is I'm going to start with something that is not hydrogen or oxygen, all right? And so since my magnesium is balanced, I'm going to start with chromium. All right, so if I have 2 on this side and I want 2 on this side, I'm actually going to put a 2 right here, which changes the amount of chromium I have from 1 to 2. All right, so that's step 1. And now I'm going to say, okay, this is balanced. My magnesium is balanced, but my oxygen is not balanced. I have 3 on the reactant side, and I only have 1 on the product side. So I'm going to put a 3 right here. So that'll change my oxygen to 3, right? 3 times 1. But I also put the 3 in front of this magnesium. So now my magnesium changes as well. So that would be the 3 times 1. So my magnesium is 3 as well. So I've balanced chromium, I've now balanced oxygen, but in the process, I unbalanced magnesium. So and magnesium's by itself, so this is nice. Because if I add a coefficient right here, it's not going to affect anything else. So I'm going to put a 3 here, and that'll go from 1 to 3, because 3 times 1 is 3. And so I have balanced my chromium, my magnesium, and my oxygen. So this would be my complete balanced chemical equation. You'll notice that we didn't put any coefficients over here. If it's helpful to you to put a 1, that's fine. Just to remind yourself, oh, there is a number there. But just like with other things, if it's 1, we assume it's a 1 and we don't actually have to write it. So it's up to you whether or not you put a 1 in front of something that just has 1 or not. All right, so at this point, your notes should be finished. You want to bring them up and show them to me for a note check grade, and then move on to the next thing.